Okay, so where does this go next? We just started taking the derivative of the derivative. So it's important here as we wrap up this third unit that we really kind of put into context what it's describing. The second derivative, we'll focus on it for a moment because when we talk about applications in and outside of mathematics, really we don't get a lot past the second derivative. We certainly can, and there are some moments, but really we want to focus on what the second derivative tells us. Well, if the derivative is the rate of change of a function, then the second derivative is simply the rate of change of the rate of change. That's what it is. It's the rate of change of the rate of change function. So we're describing that idea. And it's got a lot of applications. First of all, in physics, we associate if we think about position, its rate of change is its velocity, but the rate at which that is changing we refer to as acceleration. And we'll look at that in Unit 4, the connection between position, velocity, and acceleration. Another thing we're going to be very interested in just from the mathematical side is we'll be able to apply and analyze the graphs of functions not just to determine their rate of change, but also the rate at which that is changing as well. And just to kind of plant that idea here, think about an exponential graph. You understand what the graph of an exponential function looks like. It has an increasing rate of change from left to right. If there's exponential growth, I should say. If it's decaying, it's the opposite. But if you think about an exponential growth function, from left to right, it increases. Well, one of the properties of it being an exponential function is that not only does it have an increasing nature to it, but the rate at which that rate of change changes is also itself increasing. And that's something we're going to be really interested in talking about as we start looking at some of the applications of differentiation in Units 4 and 5.